Okay guys, right off the bat I have to say turbocharging this 292 inline 6-cylinder Chevy, the other guys, was awesome. I spent a lot of time last night doing that and got the video up, spent even more time editing it. So basically there's just no sleep. But this was awesome and the thing responded really well to turbocharging. But there's a lot of stuff in the video that I wanted to cover that I wasn't able to cover because let's face it, I didn't want the video to be 30 minutes or 45 minutes or an hour long because I don't expect you guys to sit through that stuff. But there's so much more stuff that I wanted to cover and there's a lot of good comments and stuff. So I want to take a little bit of time and cover the stuff that I need to cover now on this motor because it was awesome. So first off, a lot of guys are wondering, hey, why did you use that stupid stock intake manifold? The hole in it is so small, it doesn't flow, it doesn't make any power. We know that a better intake manifold will definitely make power. There's a lot of good stuff. There's Clifford stuff and Offenhauser. There's a lot of like cool stuff from the Aussie guys. But the reason that I stuck with the stock intake manifold on this, as a matter of fact, if you notice, I stuck with basically stock everything. Stock intake, stock exhaust manifolds. We even ran the stock distributor and point style and an original coil that came with the motor. I know nothing about it. I just know that especially after we reduced the plug gap, which we do on almost any application, the thing worked great. And that's really why I stuck with the stock stuff originally. I mean, to begin with, I wanted to show guys what they can do with that stock stuff. Because if anybody has one of these motors, they're going to start out with a stock combination. So how much boost can I run with that? How much will the stock points take? You know, how much airflow and how much power can I get through the stock manifold? Now, obviously one upgrade we did make, and I didn't try running it with the factory carburetor, but it would have been interesting. The problem is, I didn't have a way to tune that, and even when we installed this Holley 2-barrel, I had to put a lot of jetting in it. I mean, I had to go from 74 jets all the way up to 96 jets to get the air fuel in kind of a safe area where I felt, okay, this is fine, we're making lots of power, but it's working well and the air fuel is what I want it to be. So that's why I ran all of this stock stuff. The stock exhaust manifold, it's cast iron, it's heavy duty, it'll last forever, but the other thing is pretty well insulated, so it provides all of that hot air to our turbo. As you saw, it wasn't an ideal choice of the turbo, but we're going to get into that in a minute. So the stock exhaust manifold worked fine. The stock intake manifold worked fine. The stock distributor worked fine, especially when we reduced the plug gap. So if you have a motor, a 292 Chevy inline 6-cylinder, you know you're one of the other guys, and it's all stock, and you just want to add power to it without spending a ton of money on an intake manifold and a camshaft and a ported head and the lump port and all that stuff, you can do that, and that's what I was trying to show. I stuck with the stock stuff purposely to show you guys what you could do if you just have this motor and want to add a little boost. But there's even more. Okay guys, now that I've told you why I stuck with the stock stuff originally to begin with, and obviously we're going to do mods and I'm going to talk about that in a minute, but one of the things that everybody brought up and the things that I'm really excited about testing obviously is a new intake manifold for this combination. There's a lot of good ones. There's the Clifford and Offenhauser and the Aussie stuff, and I have some that are coming to me on loan from great guys that reached out and said, hey Richard, I want to help out, how can I help out? So if you're watching this and you're one of those guys, thank you, and if you're another guy that has something that you want me to test, I want to put it on there, because one of the things I want to do is I'd like to do an intake manifold shootout, and I want your guys' opinion, so make sure to comment. Should I test these intake manifolds on a stock motor? Or should I test them maybe on a modified motor after we put a ported head and a camshaft at least? Now I'm going to keep the bottom end stock for right now. When I take the head off, if I do a head upgrade, I'm definitely going to take the motor apart and put ring gap in it and check it. Maybe I'll hone it. But let me know what you guys want. I mean, should I keep that part of it stock and then just do the top end stuff with the ported head and the camshaft and obviously an intake manifold? But we need to get back to the intake manifold. So I want to do an intake shootout. Should I do that stock? Should I do it modified? Should I do it maybe both ways for separate videos? Let me know in the comments what you guys think. But here's also my thinking on an intake upgrade. I have one coming and I'm going to put it on. I'm going to try it and see how much power it has. A 4-barrel is definitely going to make more power with a good intake than the factory like carburetor setup, and obviously maybe more than this 2-barrel does. But here's my concern, especially if we're blowing through this, because the cool thing about putting a manifold on that I can run a 4-barrel with is then I can blow through that, put a CSU or 850 4150 carburetor on there with, you know, boost reference power valves and all that stuff, so I can tune it under boost. I can put that on there and it should work really well. But here's my concern. I mean, in the video, we almost doubled the power output of our stock combination. So you're getting up to where that's a fairly serious power gain. And even with an intake manifold that has the 4-barrel carburetor, My concern really is distribution. So I know I can get enough fuel to it, and with a 4-barrel and a good manifold, I can get enough air to it, especially for the stock motor, because after we cure the intake problem, the next problem is going to be the head flow and the camshaft and yada, yada, yada. So, but if we cure the intake manifold and I can blow through that, my concern, even with that intake design, is going to be fuel distribution. There's no guarantee that blowing through the carburetor or even drawing through the carburetor that all the cylinders are going to get an equal amount of fuel. I just don't know how you can make that happen. And since we're running a stock exhaust manifold, I don't know how we can measure that. You know, not really any way effectively. I can't get a measurement from each individual port and tell you what the air fuel is and what the distribution is. And that becomes even more and more of a concern once we start adding boost. Because once we start adding boost, we have less room for air and the margin gets really slim, and that's how you blow stuff up. So I think the cure to that is I want to try these different manifolds and see what happens. I may try 1 or 2 of them under boost and not go crazy under boost, but I think the cure for distribution for me is to make my own manifold. I think I have to make an EFI manifold, and I'm going to make a port EFI manifold. But again, this doesn't have individual ports for each cylinder. They're Siamese ports. So am I really getting equal distribution by putting an injector there? And should I put a single injector there for each Siamese port, or multiple injectors there for each Siamese port? So there's a lot of cool stuff that we're going to cover, which is awesome. And that's why I love doing something new, because you get to learn all kinds of great stuff. But there's even more. Okay guys, here's where I want your input. I want you guys to make sure and comment and let me know what you think, because I'm a little concerned. You know that I ran the wrong size turbo for this, the 76 millimeter. I walked over and grabbed it. Now I also had a GT45 turbo, which flows more than this, and I think it would be even less responsive to this, but I did try it and it would be an interesting test. Now just recently, I think I came across an even smaller turbo, and I think it's a 62 millimeter, which kind of maybe put it right in the sweet spot for this combination. I used it on a land speed record that we did with the guys from Suzuki. We ran a Kazashi and it went over 200 miles an hour. And I've run it on the dyno, I've done a bunch of stuff. I completely forgot about the turbo because it's probably been sitting for, I don't know, 5 or 6 years or something in a box, and I just forgot about it. So I think I could run that, but here's my question, and here's what I want you to comment about. If I do put a smaller, more responsive turbo on it, because the other thing I have is I have a couple of GT40 or GT35 turbos that are T3, so I can make a T3 adapter and run a smaller turbo. But here's my question. If I do run a smaller turbo and we get the thing to have, let's say, 7 pounds or 8 pounds or 10 pounds constant all the way through the curve, having more boost, more torque, and more cylinder pressure is what is really hard on connecting rods. And unless you're a diesel guy, I normally don't like people having full boost, full load at 2,000 RPM. Now, we probably could get away with that, but here's my concern. Running a distributor with a centrifugal advance, can I get the timing right, as low as I want, at 2,000 RPM, and still have the timing right at other RPMs as we go up in RPM and the boost is consistent? So I don't know if I could get exactly the timing that I want with a simple distributor, which makes me lean more toward an EFI setup with port injection and full control over the timing. So even if I put like the throttle body injection in here, because we're using the same manifold, the fuel distribution is not going to be improved because it's still the same manifold design. So I'm running across that and the problem with ignition timing. I want to make sure, because that's what saves the motor. If you have too much timing under boost, you're going to hurt it. And especially since these are old, tired cast pistons. The one thing I did notice, and somebody pointed this out and they also noticed it, is that as this motor was run more and more and I ran the boost more and more, it seemed to get happier. The blow-by was less, and we see this fairly often. If you run a good shot of nitrous or you run boost on it, it tends to make the rings seat even better, which is awesome. So basically, I just rebuilt it by running boost. So here's my takeaway anyways. Timing, I'm concerned about running a distributor. So I want to make sure that the timing is right, especially if I go to a turbo that has even more response. I mean, we all want to see a big 500 foot-pounds or 600 foot-pounds or whatever the number is. We all want to see it down low. We like that stump-pulling grunt that these things are famous for, and we can get that with a lot of boost. But the only way to get that safely is to make sure you have the right amount of timing, which is quite a bit less timing than we have at the horsepower peak and even less than we have at the torque peak, because down low, at that low RPM, it needs less timing anyway, and even less under boost. Okay guys, I know you're probably tired of listening to me, but I got one final thing. The last thing is future mods for this combination. Now I've already told you that I ran this stuff stock because I want to show what a guy could do that has the stock combination. I think that that's very important. I love going to the wrecking yard, getting a motor and running it through the paces. One thing I didn't do that I'm going to do with this is I'm going to run nitrous on it too, which will be very cool. Again, like with the boost, running nitrous on this thing at a low RPM, at the RPM range that all the nitrous guys tell you, do not engage your nitrous below 3,000 RPM or 3,500 or 4,000 or whatever the number is. Only the diesel guys run it at 2,000 RPM, but that's what we're wanting to do with this. So that should be interesting. But I want to talk to you about future mods. So here's my plan, and let me know what you think, guys. Make sure to make comments and let me know what you want, because I'm doing this not just for me, I'm doing it for you guys. You guys have these motors, you guys do stuff to them, and I'm doing this to show you guys what works and what doesn't, and what we can do cheaply and what we maybe have to spend a little bit of money on. So here are the future plans for this. What I'd like to do is, obviously, I want to put a cam and springs in it. Just with the stock head, a mild cam, show guys, hey, if we put in an RV cam and then this thing, what happens? So a guy can do a cam upgrade. I want to do a head upgrade. So if you're a cylinder head guy out there, or you sell cylinder heads for these 6 cylinders, please get in touch with me. I want to test one of the heads. I don't want to keep it. I'll give it back. I don't care about that. I just want to show people what it does. And it would be best to show something that a guy actually has for sale. I don't want to port it because what I do is going to be different than what a guy is going to go buy, because I'm never going to sell anybody a cylinder head. So if you have something and you're one of the 6-cylinder guys, make sure to get in contact with me and let me test it, and then we'll just get it back to you. So I want to do a ported cylinder head. When we do the ported cylinder head, we'll have more spring rate on it. We can put even more camshaft on it. And then that's also when I'm thinking about doing the intake test. I'd like to maybe do the intake test stock and then do the intake comparison after it's modified, so we can show more, because an aftermarket intake manifold is just going to show more power on a modified combination. So if we do a ported head, a camshaft, and an intake manifold, that'll kind of be what most guys are doing. And that's leaving the short block completely stock. I will change the ring gap because you know we're going to run boost on it, and as I said, we're also going to run nitrous. But what happens after that? I mean, should I go forge rods and forge pistons and, you know, do some machining and maybe some cleaning? Because obviously it deserves it. I mean, look what it's already done, which is awesome. But if I put forged stuff in it, and I've got a ported head, and we have a good camshaft, and I have ARP head studs and, you know, all the good stuff, then we can really turn the boost up. But we're right back to the same thing. If I really turn the boost up, I need these other things. I need port injection. I need full control over the timing. We obviously have a good intercooler. We've got plenty of turbo. Maybe I can run single. Maybe I can run twins. Maybe I can run a big one. Because obviously we're going to rev the motor higher when we do all that stuff to it. If you can't tell, I'm really excited about this. This is my first time running one of these, and I'm already in love because it's awesome. Thanks for watching, guys. Make sure to like, share, subscribe, but make sure to comment about all this. Let me know what you think. Let me know what you guys want, and I'll keep testing.